Hey guys, today we are going to continue our polynomials unit and talk about what actually defines a polynomial, and we're going to perform the 4 basic operations: addition, subtraction, multiplication, and division using those polynomials. So make sure you write down your essential question, and we're going to be on that notes skeleton that I passed out in class. Okay, so the first thing we need to do is fill in some of these blanks. So a term is an algebraic expression that can be written using constants, variables, multiplication, and division. So basically that's talking about a monomial. The constants in a term are called the coefficients. So when you're talking about a leading coefficient, we're going to be talking about the number in front of the variable. Okay? A polynomial can be written using those terms in addition and subtraction. So that's just saying I can add a couple things together and it's now a polynomial. The term of the polynomial, which does not include a variable, is called the constant term. Any letter can be used. So we've talked about this before. This isn't anything brand new, but there are a couple of things that make a polynomial. And the first one is that all exponents have to be whole numbers. So you can't have anything that has a variable in the exponent and still call it a polynomial, or you can't have a fraction. Okay? The next thing is that no variables can be in a denominator. That's considered a rational expression. It is not a polynomial. Okay? Because if x happened to be 0, then we'd have an issue. And finally, and this kind of goes with the first one, but no variables can be under a radical. So you can't have square root of x or something like that. That doesn't make it a polynomial anymore. It's a square root. Okay? So that's kind of basics of it. So let's talk about examples of polynomials. So a polynomial might look like x cubed minus 6x plus 1/2. Okay? It's okay that there's a fraction in there because it's not in the exponent, so we're good. Just like we could have different letter and maybe a decimal. Okay, y minus 6.7. That's also a polynomial. You're allowed to have decimals as long as they're not in the exponent. Another example of a polynomial could be just the number 12. Okay, because that's considered a monomial. It fits all those criteria. It's just a number. Okay, it's basically a polynomial is just a collection of those terms that are being added or subtracted. Okay, an example of a not polynomial might be, for instance, 3 to the power of x minus 7. This one doesn't have a whole number exponent. You can't have a variable in the exponent, otherwise problems. Okay, the other one you might see is something like this, where you have x in the denominator. You can't have a variable in the denominator, otherwise it's not a polynomial. And another example you might see is maybe x to the 1/2 minus 4. Okay, this isn't a whole number exponent, that's a 1/2, and if you remember back in Algebra 2, we actually know that a fractional exponent means the same thing as a root, so that would be a square root of x minus 4, so now it doesn't fit under the no variables under a radical rule. Okay, so that's an example of a polynomial and what's not a polynomial. Now this next part should be a little bit new for you. We're talking about the degree of a polynomial. Okay, so basically what the degree is, it's just the exponent of the highest power of the variable. So the coefficient of this highest power of the variable is the leading coefficient. So these two terms are super important for when we start graphing polynomials. So basically, if you look at these examples, to find the degree, all you have to do is find the highest exponent in your polynomial. So we have 7, 3, 2, 1, and then technically 0. So this right here is the highest powered term. So that means that my degree is whatever that exponent is. So my degree is 7. Okay, I look at this term and I see what the constant is in it, and that's 6. So that's my leading coefficient, positive 6. And then the constant term, the one that doesn't have a variable on it, is going to be that plus 10. Okay, sometimes you may not have things going on. This is just x cubed, which makes it pretty straightforward. That's obviously the highest power, so it's a degree 3. The leading coefficient, don't forget there's that magical ninja 1 in front, so my leading coefficient is positive 1. And then I don't have a constant term here. Technically this is plus 0, so I don't have a constant. There is no number that doesn't have a variable. This next one is a little bit trickier. We have 12x to the 0. Now, the weird part here is we actually do have an x hiding in this expression, and that x is raised to the 0 power. Remember, anything to the 0 power equals 1. So this is just saying 12 times 1, technically, with me adding that x to the 0 power n, which means that this is a degree 0 polynomial, okay? And then if I look in front of my x to find that leading coefficient, it's 12, okay, the number in front of the x. This is also kind of weird because there's not a constant term technically then, but it's just a number by itself, so the leading coefficient is the constant term in this case. You're not going to see a lot of monomials that are just numbers, so hopefully that doesn't show up too much. Okay, this last one, be careful here. You see a 6, a 7, an 8, a 1, and then that's technically a 0. So they don't have to be in order. You just look for the highest exponent in here. It's that 8. And so when I write this down, I know that my degree is 8. My leading coefficient, remember there's a 1 in front, so it'd be a negative 1. And then my term that's all by itself is negative 4. Okay, so important part, finding the degree of a polynomial. The polynomial functions that you've seen before, if they have a degree less than 5, you might see them called certain things. So first degree polynomials are called linear functions. So that would be like if you had y equals x plus 3. Okay, this right here, the highest exponent on the variable is 1, so that's just 1x, so we'd have a linear function. Okay, second degree polynomials are quadratic, so we've seen those too. We have x squared minus x plus 2. Highest degree is 2, so it's a quadratic function. Then we have cubic functions, which again is a cube, and then quartic. You may not have seen quartic as much, but they're going to reference quartic. That's to the 4th power. Alrighty, so let's talk about a little bit of these operations that you're going to have to go through when you have polynomials. The first one is pretty basic, adding and subtracting polynomials, just like what you used to do in Algebra 1. To add or subtract polynomials, all you have to do is combine like terms. Remember, when you are combining like terms, though, you don't get to change the exponents on it. Because when I have an apple plus an apple, I don't have an apple squared. So you're just literally going to add up the things that match and then take the variable along with it. The hardest part about these guys is when we have the minus. So when we have a negative in front. So this is taking this first polynomial minus the second polynomial. And if you notice here, and you remember there's technically a little ninja 1 here, and so you'd have to distribute that negative 1 inside. And all that does is change all your signs. So one of the things I like to do is just to go in here and physically change all the signs. So that's a minus 2x cubed, this would be a plus x, and this would be a minus 4. So now I can just combine like terms and find the things that match up. So I have negative 2x cubed plus negative 2x cubed, which would get me negative 4x cubed. Okay, and then I have x squared, has no friend, so he's just x squared. I have I don't know how to do more lines. Okay, I have a negative 4x plus an x, so that'd be negative 3x or minus 3x. And then finally I have a 1 and a minus 4, so that would be minus 3. Okay, so again, you just combine, collect things that match, add them up, done. Multiplying gets a little bit more tricky. When you have a multiplication problem, you are either going to distribute, or some of us might know this as FOIL. Technically, when you distribute and you're using FOIL, you're just double distributing. Okay, so when you multiply polynomials, make sure you are using that FOIL method. So when I do that, remember, I'm going to take my first term and multiply it by every single piece in the second thing. Okay, so this right here, I would take 2x times x squared, which gets me 2x cubed. Remember, you have x to the 1, you add the exponents together. 2x times 3x is 6x squared. Okay, and then 2x times negative 5x is negative 10x. Okay, I'm going to see if I can move this down. Oh, not the whole thing moved. Okay, but you can't forget that other part. You technically have a minus 3 getting multiplied too, so you're going to distribute that second piece to the everything. Kind of looks like a claw, it's kind of gross. Okay, so you have minus 3 times x squared, so negative 3x squared, negative 3 times 3x, so minus 9x, and then negative 3 times negative 5 is positive 15. Then it's going to look exactly like the problem up there where we just combine like terms. So no friend for x cubed. We have these 2x squared, so it'd be plus 3x squared, minus 10, minus 9, so minus 19, and then plus 15. Okay, and again, if you want to use the box on here, that's fine. Just remember to put enough boxes in there, but distributing works just as well. And the last thing, it's kind of tricky when we're dividing polynomials, and there are two different ways to do this. One way is called synthetic division, and one way is called long division. So here's an example. We're going to work it both ways just so I can show you that it works the same either way. And the biggest issue that we have with synthetic division is that it only works in a certain case. So like when we did long division back in the day, maybe I had 4 divided into 3, 7, 2, 1. When I divide this using long division, I'm like, hey, can 4 go into 3? Nope. But can 4 go into 37? Yeah, it can go in 9 times. Then I multiply 9 times 4. Hey, that gets me 36. And then I would subtract. So I subtract that, I get 1, and I pull down that next number. Okay, 12 times 4 is, 3 times 4 gets me 12. Pull down that number. So I got 0, 1. So can't go into 1, and then I have a remainder. You are allowed to have remainders on these. So let's talk about how you can use synthetic division. It's just like what we did in elementary for long division. So synthetic division. This only works when the divisor is a first degree binomial. So that means it has to only have 2 terms, and it has to be to the 1 power. So it's like x minus 2, x plus 4, x to x, I don't know, whatever, plus a number or minus a number. Now, the weird part about this one is that when you set this up, you're going to recognize it from Algebra 2, but if this has a minus here, that means you're going to write a positive 2 inside your little box. It's basically what number is going to make this factor into 0. Okay, so basically you're changing the sign, or you're thinking what's going to make this factor 0. Then what you're going to do is you're going to list out all of the coefficients of the second variable, or second expression. So the only problem with this one is we have 3x to the 4, and then we have 8x squared. We missed a term in here. There's a 0x cubed. So I do have to remember to put that 0 in there. So I'm just going to list out my coefficients. I have x to the 4th, x to the 3rd, x to the 2nd, remember keep the negative, x to the 1st, and then technically x to the 0. Okay, so this is every single coefficient in that thing. Now what you're going to do is you're going to bring down the first number, which is 3, and then we get to multiply. So we're going to take this number, 2 times 3, and write it right here. So 2 times 3 is 6. Then we just add down the line. So 0 plus 6 is 6. 6 times 2 is 12. Okay, negative 8 plus 12 is 4. 4 times 2 is 8. This guy added up is negative 3. Negative 3 times 2 is negative 6. And then that's going to get me negative 5. Okay, this right here, this is going to tell you your remainder. So when I multiply this out, or if I multiplied it out, I'd have to add a negative 5 to make sure it's there. Okay, and so finally what I do is I take these coefficients and I make a new expression out of them. So I'm going to have my first coefficient is a 3x, and you're going to start 1 degree lower than what you had. So this right here, it was a 4, so I'm going to have a 3 here. Okay, then plus 6, next coefficient or next exponent down, 4x minus 3, remainder negative 5. Okay, that is your answer. And here's basically what we did. In a nutshell, synthetic basics. We brought down our first number right here. We multiplied the 2 numbers together. We added down that column, and then we kept going until we reached the end. Your answer is going to be 1 degree less. So if you want to pause and write this down for yourself, cool. The second method that you can use here is long division. Oh, I need my question. Okay, long division is going to work almost exactly like you did it back in the day, except for this is the only method we can use if we don't have a first degree binomial. So if you had x squared minus 2, this is you have to use long division. I'll show you though that it works, and it should get you the same answer as the first one. So we're going to write just like a long division problem. We have x minus 2 as my divisor. So then I have 3x plus 4, or sorry, 3x to the 4. Don't forget that 0x cubed. And now we're going to work almost the same way. Now, one thing I do like to do is I like to skip this first spot just so I make sure everything is lined up. So I think about how many times, what do I need to multiply by x in order to get 3x to the 4? Well, I need a 3, and then I need 3 more x's. And so if you notice, I line up my cubes. Okay, so now I'm going to take this and I'm going to multiply it to both of these terms. So I have 3x cubed times x is 3x to the 4, and 3x cubed times negative 2 is going to be minus 6x cubed. Okay, now we're just going to subtract it like we did before. Now this is the only part where I think it's tricky, because remember, you are subtracting this whole thing. And so before, what we saw, you had to distribute that negative. This guy's going to cancel. It should. But this one is going to turn into a plus. And so now you have positive 6x cubed. And then you bring down the next term. And you play the same game. How many times does x go into 6x cubed? Well, it goes in 6x, and we need 2 more x's. Okay, multiply. So 6x cubed minus 12x squared. And then I'm subtracting that. Be careful, you're subtracting the whole thing. This goes away. This is going to turn into a positive 4x squared. Bring down your next term. Okay, same deal. We're just going through here. We're saying, what do I need to multiply by to make that term? I got 4x squared minus 8x. Hardest part about this is to remember that you are subtracting. So that's going to be minus a minus, so it should be a positive 3x, or sorry, negative 3x. And finally, I have a 1. Okay, and so then I think about how many times does that go in? Minus 3. So I have minus 3 times x, and then positive 6. Subtract those guys, and so this is really minus 6. That gets you negative 5. Remainder, negative 5. So if you look here, we got the same exact answer. The process was a little bit longer, but remember, this is the process you'll have to go through if it's not a first-degree binomial. So if they had wanted me to divide by something bigger. Okay, last but not least is how you can check your answer. So if you needed to check your answer, you weren't sure, you had some extra time on a test, you can take the answer that you got, multiply it by the divisor, so whatever they asked you to divide by, and then add that remainder, and it should get you your original problem. Okay, I hope you guys have a great night.